The scatter plot below visualizes the median income and poverty rate for the United States. If needed, refer to the statistical tool and data to answer these questions. Now, if you recall back in question 2, the scatter plot that we created had median income in the Y position and poverty rate in the X position. But it doesn't really matter because, as we know, the correlation coefficient will be the same. So when we recreate this plot, we're going to put poverty rate in the Y position and median income in the X position, which is backwards from what we did last time, but it'll be okay. Then we are going to be asked to identify the coefficient of determination and explain what that means, and identify a point on the scatter plot that would increase the coefficient of determination if it were removed. We can do that. We can do that. Let's get our tool. And we know we're going to enter our own data. Enter our own data. And we're going to put poverty rate in the Y position, which is backwards from what we did in the last problem, but that's okay. And median income in the X position. Let's go get our data. And we'll put poverty rate in the Y position. There we go. Poverty rate in the Y position. Good. Alabama has our 16.8. That's good. And let's get our median income. Good. Alabama, 49,861 with a 16.8. Alabama, 49,861, poverty rate of 16.8. Okay, we got them in the right order. They have to be in the right connection. Otherwise, the concordance, the correlation, is spurious. It means nothing. Let's see what that scatter plot looks like. That looks like the prompt. That looks right. Good. And we've asked for the model summary statistics here. And so it gives us the intercept of 27.23 and the slope. It's different intercept and slope than we saw when median income was in the Y position, poverty rate was in the X position, because the X values have changed. So when X equals 0, that tells us what our predicted Y would be. If we change what the X is, then that has to change what our predicted Y will be. These are the two components of the linear equation that represents the best fitting line. Let's click regression line, and that gives us our best fitting line. This is the line out of the infinite number of lines that could fit through that scatter plot, the line that has the least squared error, where overall across all observations, the squared deviation from that line when summed up, is the smallest possible value. It's sometimes called the line of least squared error, or the regression line. We saw this before. The correlation coefficient is negative 0.842. The coefficient of determination is essentially the square of the correlation coefficient. Negative 0.842 squared equals positive 70.9. The coefficient of determination represents how much shared variance there is, how much of the total variance in the poverty rate is explained by the median income. Coefficient of determination 70.9 means 70.9% of the total variation in poverty rate is explained by median income. You can see some of these values have a pretty far distance from the prediction line. And some of them are very close. That point is exactly on the prediction line. That point has very little error. Those points have quite a bit of error. Let's go back to our questions. The coefficient of determination for the data is r squared equals 0.709, or 70.9% of the variance in poverty rate is explained by the variance in median income. If we had a perfect correlation, we would explain 100% of the variance. That is extremely rare in the social sciences. So what does that mean? 0.709 equals r squared. Well, in general, the coefficient of determination represents the, in this case, if it's 0.709, proportion of the total variance in y that is explained by the variance in x. How much they cohere. In this case, (0.709) represents 70.9% of the variance in poverty rate is explained by variation in median income. That's a lot, by the way. Identify a point on the scatter plot that would increase the coefficient of determination if it were removed. Okay, let's go back to our scatter plot. So when xy coordinates, these dots, are close to the prediction line, you explain a lot. It's a very close coherence between the x value and the y values across all. And when the xy coordinates deviate a long way from the regression line, it reduces both the correlation coefficient and the square of the correlation coefficient, the coefficient of determination. So if you wanted to arbitrarily increase the correlation and the coefficient of determination, you could remove outliers. And so in this case, we would look for values or xy coordinates that are a long way away from the prediction line. So this one seems like its median income true is 75.277. The predicted is 75.5. This one, the true median income is 44. The predicted is about 44.317, 44. So 317 units difference, 75.277. This one's probably a little bit further. So we would remove state number 24. And that would then make this cohere a little bit better. We're going to remove highlighted state number 24. Whoever that is, let's see who that is. State number 24 is Minnesota. Minnesota. Okay. To increase the correlation coefficient and the coefficient of determination, we would remove state number 24, Minnesota, my hometown, which has a large deviation or residual from the predicted value.